Hi everyone. The next topic from E module is basically continuation of quadratic equation, which is E3 types of solution and nature of tools. So let's begin with the first one. We have to find the number of positive integral solutions to the following equation: 4x minus 17y is equal to 1, where x is less than or equal to 1000. Now, if you remember the theory of this, the number of integral solutions of a linear equation, what did we learn was that you need to find out the first value by trial and error for x and y, which will satisfy the given equation, and then just change the values in the cross format. And if there is a plus sign in between, if you increase one value, you will decrease the other value. And if there is a minus sign in between, then if you increase the one value, then you will have to increase the other value and vice versa. So the first value of x and y, which will satisfy this equation by trial and error, is 13 and 3. Then next one is the values of x will change in the factor of 17 and the values of y will change in the factor of 3. Sorry, in the factor of 4, which is the coefficient of x. And because there is a minus sign, so we are increasing x, so we'll have to increase y also. So the next set will be 30 and 7. Similarly, the next set will be 47 and 11 and so on. So if you remember, they said that the values of x less than or equal to 1000, and you are seeing that x is starting from 13, 30, 47, 64, right up till 1000. So how many values are there? Now to calculate this, you can use two approaches. Either this is AP and you can find out nth term, which is less than or equal to 1000, using the formula for nth term of an AP, arithmetic progression. This is where the interconnectivity between the topics will be very critical, that you remember the individual ideas so nicely that only then you can apply it somewhere like this where it is required or where it is applicable. The other way is you try to form an equation. All these values can be written in terms of 13 and 17, some multiple of 17 plus 13. So 30, the first value, can be written as first multiple of 17 plus 13. 47 can be written as second multiple of 17 plus 13. 64 can be written as third multiple of 17 plus 13, and so on. So generally, the format of the equation can be 13 plus some multiple of 17 less than or equal to 1000. When you solve this, you'll get the value of n as 58. Now, folks, don't mark this answer, which is also present, because if you remember, all these we started doing from 30, which is the second value. The first value that x had was 13 as well. So we need to include that as well. So 58 plus 1, total there are 59 solutions are there, which will satisfy this equation. So option 3 for the first question. Exactly similar is the second question, and what it talks of: x and y are the integer, then the equation 5x plus 19y is equal to 64 has dash solutions. So how do we think about this? So the first value of x and y by trial and error will be 9 and 1. So 5 into 9, that is 45, and 19 into 1, that is 19. 45 plus 19 will give you 64. And because there is a plus sign, so if we increase the values of x, we'll have to decrease the values of y. So the values of x will keep on increasing by 19, and the values of y will keep on decreasing by 5, which is the coefficient of x cross format. Now, first value of x was 5. If I increase that by 19, I'll get 28 is the next value. Then if I further increase by 19, I'll get 47. Then if I further increase that by 19, I'll get 66, and so on. Those are the values of x. And the values of y, I'll have to reduce by 5. So first value was 1. If I reduce that by 5, it will be minus 4. Then if I further reduce that by minus 5, it will be minus 9. If I further reduce that by minus 5, it will be minus 14, and so on. So what you understand from this equation, that is, the values of x are increasing by 19 and the values of y that are increasing by 5. Sorry, decreasing by 5. Now coming to the options, what you understand is third option is the answer because all the other values or the options will not be sensible here, because the first option says there is no solution for x less than 300. And you would have seen that we have already found out 4 such values of x for which we are getting the answer, or values of y that are less than 0, that is negative values of y, there is no solution. But the second value itself that we got, which was -4, is a negative value and we are getting a solution. So those options are wrong. Similarly is the second option, no solution for x greater than 250. Obviously, why not? Because we can keep increasing x by 19 every time. There will be a point where the value of x will cross 250. I mean, so because of that, third option is the answer. Why third option is the answer? And the reason that I did not go ahead with this solution is that in the initial this half, they have done the mistake. They have just copy pasted the same part of the previous solution. So those are not the correct answer. So don't get confused. The values will be 9 and 1, then 28 and -4, then 47 and -9, and so on. Now, so what we understand is option 3 says a solution for x between 250 and 300. So between 250 and 300, x has a choice of 50 values. And we now know that x is changing in the multiple of 19, in the factor of 19. So that means among those 50 values that x can assume between 250 and 300, there will be definitely two solutions that x can take, because 19 twos are 38. So that tells us clearly that no brainer it is that there will be definitely one solution for x when x is between 250 and 300. In fact, I can guarantee you there will be two such solutions because 19 twos are 38. So considering all of this, option 2 is the correct answer. Third one, again, 3 variables. So as I said in the E1 topic, it is not the part of the syllabus. So we'll discard this. Fourth one, what is the value of k for which the following system of equation has a no solution? So no solution, linear simultaneous equations, we have seen the concept, 3 cases. No solution ka case was a1 upon a2 is equal to b1 upon b2. When you just substitute that, straight away you will get the value of k as -1. Option 3 for the fourth question. Fifth one, find the value of m if the equation 2x square minus mx plus 3 is equal to 0. The roots are real and equal. So if you remember, the condition for roots are real and equal was the value of delta that is equal to 0, and delta is b square minus 4ac. So when you compare your original quadratic equation with the standard form, you will get the values of ABC. Then just simply substitute and solve. That gives you the answer that m is root 24. Root 24 when simplified further will get 2 root 6 as the answer. So option 1 for the fifth question. Just need to remember all these formulae and concepts and the conditions very clearly so as to apply them effectively. Sixth one, q is a positive number. Find the smallest value of q for which the equation will have rational roots. So for rational roots, if you remember, the condition was delta is equal to a perfect square. Now, what is the mistake that happens is student will substitute the value of q from the options. They will substitute 2, which will be giving you a perfect square. But that is not correct because q has to be smallest. Then they will substitute q as 0, which will also give them a perfect square. And they will mark probably 0 if they realize that q has to be smallest. Even if they mark 0, that is still incorrect because the question talks of q has to be a positive number. So smallest bhi hona chahiye, positive bhi hona chahiye. Because of these two reasons, and it's a trap when you substitute the values of q because both the values are wrong. So what we would actually advise is, or rather, what is the correct way of solving this type of question is, instead of substituting, what you should always look for is actually equate this equation with a perfect square. And which perfect square? The immediate lower perfect square than the one which is already present in your data. So there is a perfect square which is already present in terms of minus square, which is 49. So immediately below 49, the next perfect square is 36. So the suggestion is actually equate this equation with the immediate lower perfect square, which is 36 here in this case. For other question, it may be different based on the values. Now, when you solve this equation, the value of q that you will get is 13 upon 12, which is 1 point something, which is less than 2. So it becomes the smallest value. And it is also a positive value, which the question was asking for. And only because of that reasons, you will mark none of these. So the actual value of q is 13 by 12, 1 point something. So this is the way you need to think about all these questions. Seventh one, alpha and beta are the roots of the equation. And then we have to find out a equation whose roots are 1 upon alpha and 1 upon beta. Now the idea here is this is actually 5, 10, 15, 30-second shortcut kind of a question, one of its kind. So what you need to remember is, suppose you have an equation whose roots are alpha and beta, and you need to find out another equation whose roots are reciprocal of the above roots, that is 1 upon alpha and 1 upon beta. Then the only thing that you need to do is just exchange the values of a and c. And when you exchange the values of a and c, you get your new equation, which is option 2 straight away. So guys, you just need to note down this small note. What is that note? This one. When the roots of one equation are the reciprocals of the roots of the other equation, don't do all of this long cut approach, solve and everything, because even after solving and everything, if you compare both the equations, the original and the new one, what you just observe as a pattern is just interchanging the values of a and c, and that gives you straight away option 2 as the answer. This is how some of these questions can be solved, just like that, if you can remember all these important and the effective pointers, which will drastically reduce your time taken and the calculation both. Eighth one, find the value of k in the following equation if one of the root is the square of the other one. So one root is square of the other root, basically. So first of all, instead of alpha and beta, you could have said alpha and alpha square or beta and beta square. And then here you are going to use something called as sum of the roots and product of the roots. So sum of the roots, the formula is minus b by a, and sum of the roots in this case will not be alpha and beta, it will be alpha plus alpha square, because one of the root is square of the other root. Formula is minus b by a, which is k by 3, and then the product of the roots will be not alpha beta, but it will be alpha into alpha square, which is c by a, which is minus 24 upon 3. So minus 24 upon 3 is minus 8, and alpha cube is minus 8. That means value of alpha will be minus 2. Substitute that value of alpha minus 2 in the above equation, and you will have your answer for k, which turns out to be plus 6. Option 1 for the 8th question. Similarly, 9th one, the best question of this entire sheet because of the following reasons. The value of k for which the following pair of equations will yield a unique solution, and such that the solution is a positive solution. Now, the moment you hear or read this word unique solution, you will apply something which is not the correct way, because you are going to apply something from simultaneous equation. A1 upon A2 is not equal to B1 upon B2, which is not right, guys, because that is for simultaneous equation. If you observe the equation that are given to you, they are quadratic equations. So there is something different that we need to think about. So what do we do when we are asked for a unique solution in terms of quadratic? Is that the roots are real and equal, because the differentiating factor between the quadratic equation ka root, that is alpha and beta, is that plus minus wala part, root of b square minus 4ac upon 2a. So that plus minus wala part, if that is not there, then clearly both the roots will be equal, and that translates to a unique solution as far as quadratic equations are concerned. So remember something very important, new idea. Unique solution for quadratic equation is delta is equal to 0. Roots are real and equal. So what we will do is, from the first equation, we can say that x square is equal to y square. Substitute that in the second equation in place of y square. So the entire equation becomes into x square. Then simplify this, use a minus b the whole square formula and restructure that. So x square plus x square gives you 2x square, and the constant k square minus 1, we have put them together. And now we have converted this equation after few steps of rearranging and everything. You've got it into a perfect quadratic equation format. And if you remember, for unique solution quadratic equation, delta is 0. That is b square minus 4ac is equal to 0. When you solve for this, the value of k that you will get is root 2. And that will be the answer of your question. Option 3 for the ninth. Okay, now if you remember, we had earlier kept one part from the previous topic, the last question, which was also related to this idea. And I said that we will discuss when we are done with E3. So let's do that, and then we will stop here for E3. So the ninth question from E2 was, if one root of the following equation is 4, while the other equation, they have given another quadratic equation, and that quadratic equation has equal roots, then the value of q is dash. So equal roots is what we have explored now in E3, and hence this was kept back earlier when we were discussing E2. So equal roots delta is equal to 0 is what we are supposed to apply. But in the second equation, for that we need at least the value of p, which we will get from the first line of the question. So 4 is equal to one of the roots of the equation. So root should satisfy the equation. So what we can just simply do is substitute the value of x as 4. So when we substitute the value of x as 4, we'll get the value of p, which turns out to be minus 7. And substitute that value of p in the second equation. So your second equation becomes x square minus 7x plus q is equal to 0. And that equation has equal roots, and equal roots is corresponding to delta is equal to 0. So delta is 0, yani b square minus 4 ac is equal to 0. Solve for that, you will get the value of q as 49 upon 4, which is answer option first. So this is how you can apply the concepts. So with that, folks, we are done with both E2 and E3. E2 and E3 both together will combine to give you quadratic equations, and the ideas that are associated with it. You be very careful with all the three forms of quadratic equation, the different formulae, the different conditions for roots, and then some part of linear equations, the ideas related to that, then the integer solutions of the linear equations, etc., etc. Thank you so much.